Okay, so let's take this up quickly. It seems like most people are on track, right? What do we find that we're just doing over and over again?
Same thing.
Finding midpoints and then finding lengths.
I'm gonna put down. So everybody watch up here. Two things that I've taught you so far, and they weren't even that hard. So let's see. Midpoint of a line. Right?
All the lengths times.
Those are the two things that there's just two formulas. Going back to grade 9 with its slope. So we need to apply slope. In particular, perpendicular slopes. Right? So we need to jog in memory way back grade 9 how to deal with slopes. What does it mean to have a perpendicular slope? Or in other words, perpendicular line. How does that affect the slopes? Yes, negative reciprocals.
And the first thing.
Equation of a line. That is y is equal to mx plus b. Right? Just going those concepts, we need more practice than that, we know, but it seems like we're getting concept of calculating the slopes, solving for b. Right? We need that constantly because now we're having points that are given to you, but you need to calculate it. You're given segments, you need to calculate slopes. So we're trying to see relationships between all these things. So this is drawn back way back to grade 9. Now finally, all we have to do is a review of linear systems. That's all we've done so far. Okay. One last little bit we need to do with circles, but you already saw the direction I'm going with that with the donut exercise. Okay? So all of this is just application of these things. We just gotta get comfortable with it. So for this one, as our Jordan said, we're just doing the same thing over and over again. So I'm just gonna calculate the midpoint of 1. So I'm gonna calculate the midpoint of QP. Some of us are having a hard time remembering this equation. Or this formula. So we write it out enough, we'll remember it. Think of this as averages. Average over x coordinates, average of y. So we're adding. So here we got 0 plus a negative 2 over 2, and then 4 plus a negative 2 over 2. So we get negative 2 over 2, 2 over 2. Negative 1 comma 1, which puts us right over here. So let's say that's A. So we do this repeatedly. The difficulty sometimes comes in even just doing a basic arithmetic. 4 plus negative 2 gives me 6. 6 divided by 2. Well, it's 3. Whoops. Screw that up, you screw up the rest of the question. Right? So just taking care of a basic arithmetic. Eventually you get something that looks like that. Those are the 4 midpoints. So B is 3, comma 3.5.
They don't like this one.
C is 7, comma 1. And D is 3 and negative 1/2. So those are your 4 midpoints. So you plot them. They connect the lines. What do you notice? What do we get? Diamonds. So a special name we call it diamond because parallelogram. Good. So we see that we have parallelogram in here. So hopefully you can kind of see what I did with the next question. What we're leading to is we want to calculate the slopes.
Does it always make a parallelogram? Yeah.
That's the next one. That's the next slide, Jordan. So we have the slope. So let's calculate the slope of AB. Again, This is almost like, I can almost give this as a review question for grade 9s. Calculate the slope of those 4 lines. Just fraction the slope for me. So I'm just going to do this once. Delta y over delta x. So AB, I'm going to do 3.5 minus 1 over 3 minus a negative 1. That gives me 2.5 over 4. That works to be 0.625.
0.625.
Okay?
Oh. How do you know?
What you will find that if we calculate the slope of CD, well again, it's 0.625 as well. Last class we did something about triangles and the shortest distance, or finding the height of a triangle. Which really the height of a triangle is the shortest distance from a vertex to the opposite side. So we're sort of drawing that connection with the shortest distance is given by perpendicular line. So let's calculate the slope of BC. So here I got delta y over delta x again. So we got 3.5 minus 1 over 3 minus 7 gives me 2.5 over negative 4. Cool. Okay, and we calculate the slope of AD, we actually get the same answer. Okay? So basically what we're showing here is that when I calculate those two sides, the slopes, opposite sides are parallel to one another. We got the same slope. Are they negative reciprocals to one another? Sure. Good. Right? So don't be tempted to say, yeah, there's got to be a right angle there because they're negative reciprocals. The negative, well, 0.625, the negative reciprocal of that is just not the negative number. Right? It kind of fell that way, so don't fall into that trap. So let's calculate the length of, let's do AB. So length formula is x2 minus x1 squared plus y2 minus y1 squared. See, actually, I'm smart. Where does these numbers come from? Where do we use x2 minus x1? Yeah. So we did slope calculations up here with those same points. We could just reuse those values. But I don't think I did. Did I calculate slope of AB? Oh, I did. So it's 4 squared plus 2.5 squared. So we got 16. What's 2.5 squared?
The cell is 6.25.
6.25?
6.25.
So this is square root of 22.25, which is roughly what? 11 point, no, maybe like 4 point something. Square root 2.25?
Nope.
Is it easier to do in decimals or fractions?
4.17 roughly? 4.71. 4.72. You could do this in fractions. It's a little bit hard because once we get to the square root of a number, we know that, especially for a fraction, you're going to be working with decimals. So once we start dealing with the length, it's okay. You could do it in fractions. I don't have a problem with that. Some of you just might find it easier just work with straight with decimals.
So let's use decimals now?
For the lengths, yes.
No, but like
Okay.
square root 89.
Oh yeah.
And then over.
So what we're going to find is that actually when I calculate the lengths of all these sides, what do we get? They're all the same. So really the length of AB is equal to the length of BC, so do all the math again. It's just something that you'd be expected to do. But I just want, for your sake, your sanity.
Yes, I have to do it again and again and again. Why?
Easy marks. Okay, just hold on. Before we get all excited. Okay? What is the shape? A square. It's a special name for this
A
shape.
rhombus.
It is a square.
Rhombus.
Isn't it a square? Is everything equal? Oh, so since the slope of AB is equal to the slope of DC, and the slope of AD is equal to slope of BC, and all lengths are the same. ABC, D is a rhombus. Okay. So now we start dealing with just quadrilateral shapes and really trying to how prove or verify that a given figure is a particular shape. So the first point, as Jordan already pointed out, is you take any quadrilateral, so the line segments joining the midpoints of any quadrilateral forms a parallelogram. Will it always be a rhombus? No, but it will always be a parallelogram. That's an important concept. That is sort of new. It's kind of cool. I have no idea why it works that way, but it does. So instead of drawing one, you can just pick any 4 points on your Cartesian plane. You can actually go through that exercise and verify. Any 4 points.
Like in the
And you find the midpoints of each of those line segments. And you connect them, they will form a parallelogram.
Some questions. On a testogram, we find the midpoints, we form the parallelogram from the midpoints, and as for the slope, we find the slope from the slopes.
Yeah, and then you verify that we have all the slopes, and you can prove that it's a parallelogram, right? Which brings us to the next point. To show that a quadrilateral is a parallelogram, so that it shows that a quadrilateral is a parallelogram, you need to show either the two opposite sides have the same slope. Okay, so that's one way of doing it. Another way you could do it is the two opposite sides have the same length. You could do both, but only one is necessary. And in fact, if you do one, you'll find that the other automatically happens. Either method you choose, you need 4 calculations. So definition of parallelogram is a shape where, again, it really comes down to two sets of parallel sides of your shape. So both ends or both sides, both pairs need to be parallel. Or they both have the same length. So here you're going to have 4 slope. Calculations. And this one has 4 length calculations.
No.
So the last thing I want to do is just talk about other shapes then. So what verifications need to be done to show that a quadrilateral, yes, have to. Yes, Dan.
All 4 sides are different. Well,
Sorry?
the length and width are the same. The lengths are the same and the widths are the same.
It's just, yeah. But just talk about sides, right? Talk about the sides. So we talk about opposite sides, opposite sides, right? Of a quadrilateral. opposite sides, like one side and the other side, they're not connected. Yes, Amy. Sorry? Oh, so you're answering the question.
Oh.
Is that what you're doing? Okay. So what extra verification needs to be done? Well, I'll say that before. Go back before.
Oh, 90 degrees.
So the sides are at 90 degrees. Right? I mean, that's the definition of a rectangle. It's really a specialized form of a parallelogram. It's that we have the restriction, or the one unique feature of rectangles, that angles are 90 degrees. It's a perfect square, like the angles.
Two parallel lines, two sets of two parallel.
Two sets of parallels and the sides are 90 degrees. Now, how can we demonstrate that something's intersecting at 90 degrees? Yeah, so we look at the slopes are negative reciprocals. Okay, that's what we're looking for. We're looking at the slopes. Do we want to calculate the slopes of, well, actually, here's the question. If you're asked to prove that a particular shape is a rectangle, which method would you use, 1 or 2?
Is it? As I said, negative.
2.
So we heard 1, 2. Why would you use 2?
Because just make sure the opposite ones are the same.
Okay, so you calculate all 4 lengths.
And the opposite same is not opposite.
Okay, but you have to prove that it's a rectangle, though. So what else do you need to do?
Switch every 90 degrees in the plane.
Okay, so what else do you need to calculate then? How many slopes? 2, right? You need to calculate at least 1 corner. Well, I did 4 length calculations and 2 slope calculations. Well, how else can I verify? Amy? Yeah, well, if I'm calculating slope, I could use method number 1 to prove that it's a rectangle. Right? I'm already using slopes, so I already have the slopes. I just have to do one last look. The information I'm getting, are there negative reciprocals there? Well, if they are, then not only is it a parallelogram, it's a rectangle. Right? So we can almost sort of do that with our first diamond one, the green diamond. We just did the slopes first, and we said, well, for sure it's a parallelogram, but it's not a rectangle because it was not negative reciprocals. Okay? So we could do this a little bit more intelligently to verify a rectangle. What about rhombus? What extra verification do we need for a rhombus?
All sides.
Yeah, so here, well, all sides are the same.
Same what?
The same sides.
What if it becomes a square?
Same slope.
Then it's a square.
I guarantee it's gonna pull down.
You didn't see that?
What's the rhombus?
How much you want to get back?
She got
My entire.
So all sides are the
Actually,
same.
Rhombus doesn't have 90-degree angles.
No, that's not true. Square is a special version of rhombus.
Yes.
Just like a rectangle is a specialized version of a parallelogram. By definition, a rectangle is a parallelogram. Yes, rhombus is not necessarily a square.
So an apple is a fruit, but a fruit is not.
It's like when you
Yes.
say you go to like, let's just do Florida, you ask.
Oh, good.
You
That was
you
very-
ask if you go to the.
I think I should read philosophy.
Exactly.
Anyways, back to geometry. So rhombus is really a quadrilateral. All the sides are the same length. So question here is how you go about proving a quadrilateral is a rhombus. Would you use method number one, or method number 2? For a rhombus, would you use number 1 or number 2? Why 2, Michael?
Because we're talking about sides and rhombus.
Yeah.
Right?
So we're going to prove that it's a parallelogram to begin with, but we also know that we want to check all the sides, as long as we use the thing that uses the sides. Okay? Oh, Alex called it.
Oh, 5% more on my next test.
Finally, what do we need to do to show that it's a square then?
all sides and slope are the same.
Everything is the same.
Every
Zero
point.
slope.
Every point is the same.
Well, really, what I would do is the same as the rhombus. Because you need to know that all four sides are the same length. You need to know that in order to square. Plus 2 slope
Now I'm starting to appreciate how special squares is.
calculations,
Cubes.
right? Plus you need two slope calculations to see if the sides are perpendicular. Right? So you don't need all 8 things. You don't have to go calculate the slopes of all the lines. What you want to do is look for that corner, right? Calculate the slope of one side, calculate the other slope of the other. We get a negative reciprocal, then we do have a square. Otherwise, it's just a rhombus, right? Which is what we had in the first example. Yes, they are.
So would actually have to prove that they're which quadrilaterals they are. You can't just see it.
It could be it could be a question where, you know what, I put up 4 coordinates,
So we have to do all.
classify the shape. So what would you do? First of all, plot it. Does lengths look like they're close to being the same? No. Right? If they don't look like they're the same, then you're going to start looking at the angles. Is it just a straight parallelogram or a rectangle? All of a sudden, the side lengths start looking like they might be the same. Well, I'm going to start calculating the lengths. Right? And what I'm going to do is calculate one and the one that's not opposite. Right? As soon as I got those two, they're not the same, then I could rule out that it's not a square, it's not a rhombus. And I might just go back to my slope calculations. Okay? So it's how you want to tackle it. The easier question is, verify that this shape is a rectangle.
I won't ask it, but.
I don't know what I'm going to ask you. Right? But that's an easier question, right? So you need to know and classify shapes, right? And we're just doing that with the tools that I just pointed out in the first one. We don't even have to use midpoint for any of this, right? Do we do midpoints? Only to create that quadrilateral to begin with.
True.
But here it's just all lengths and slopes. Okay, so this is for homework.
2 questions.
Yes, 2 questions. I did this on purpose because some of you did not have a chance to go back and do the previous homework. Please go back and try them. For example, the question I just gave on the quiz, question almost straight out of the textbook from homework.